2.5, linear inequalities. So as a quick reminder, if we have a less than symbol or a greater than symbol, when we put this on a number line, so I'll even put that number line, we use an open circle. When we are putting this on a graph, we are going to use a dashed, or some people say dotted line. Okay. If you are using less than or equal to, or greater than or equal to on a number line, we would put it with an open circle, and then we shade it in, so it ends up being a closed circle. And then if we're putting it on a graph, instead of a dashed line, this time we put a solid line because the answer is included within there. Okay, so again, different types of graphing that we're going to really be talking about today is focusing on regular graphs, not the number lines, and talking about solid versus dashed. Now, remember, if it is a greater than, we shade above. If it is a less than, we shade below, less than, lower. Okay, so let's get into some examples. If I'm graphing this first one, I'm going to graph it in blue. Y is less than a half x plus 1. So remember that the half is your slope, and the plus 1 is your y-intercept. We always start our graphing with our plus 1s. We're going to put plus 1, okay, on our y-intercept. And since our slope is a half, that's what we rise, and then we run. So we're going to rise 1, run 2, rise 1, run 2. And I'm going to do that just a couple different times on here. If you would like to build it the other way to the left, we just do everything backwards. We go down 1, back 2. Down 1, back 2. All right, and then let's see. I almost connected with a solid line, but it is actually a dashed line on here. So I'm putting the dashed. And then it reads y is less than, so I would shade below. All right, example number 2, I'm going to put in green. It says y is greater than or equal to 2. So you'll notice there is no slope right here, which means our slope is 0. Our y-intercept is 2. So I'm going to go to 2. Since our slope is 0, that's a horizontal line. So I'm going to draw a nice solid line across. And since it's y is greater than, we are shading above. All right. Last one, this time we have an x is less than 4. All right, since it's not a normal y equals or equation like in our slope-intercept form, what we want to remember is that when it reads x, that means it's a vertical line. All right, so on the x-axis, I'm going to go over to 4. 1, 2, 3, 4, put my dot. All right, it again is a dashed line this time. And it reads less than, so I'm going to shade below. All right, so there's some graphing on there. Now, if instead they give you an equation in standard form, something like 2x plus 3y is greater than or equal to 6, what we want to talk about on this one is you have two choices. You could go ahead and do intercept method, which is what we talked about in our notes, and I'll show that. And we could also do our slope intercept method. So if I'm going to do finding intercepts, if I find my x-intercept, I would have 2x, my y again we fill in with 0, so that would make it just equal 6. So I'm going to get an x-intercept of 3. Written as a coordinate point, it'd be 3, 0. Put that on my graph. Then when I go to find my y-intercept, remember that's when x is 0, so we'd fill in a 0, this goes away. So we'd have 3y equals 6, so y equals 2. So I'd have a coordinate point of 0, 2. Okay, I will go ahead, this is a solid line, so I'm going to play connect the dots. And it reads greater than, but really what we want to do is we want to test that point 0, 0 to make sure. So since it reads greater than, we're thinking we need to shade above. So if I test the point 0, 0, it should not work. Okay, so if I put in a 0 for x, a 0 in for y, we'd have 0 plus 0. 0 is not greater than 6, so this is not a solution. So we were correct. We should be shading right above the line. Okay, now if you have a choice and you don't like to do it in the intercept method and you'd rather just rewrite it in y equals, you could do that. So goal would be to get your line just to look like that. So in order to do that, we'd have 2x plus 3y greater than or equal to 6. So I would move my 2x over by subtracting. I get 3y greater than or equal to negative 2x. So put the variable first, plus 6. Last step, divide everything by 3. So you would have y is greater than or equal to negative 2/3 x plus 2, which matches what we have already graphed. There's your y-intercept of 2. We will go down 2 over 3 for our slope. We know that it's a solid line like we already have, and it does say shading greater than, which is what we have shaded. All right, story problem. We have a local theater that's going to charge $7.50 for adult tickets and $5 for kids. The theater needs to make at least $240. All right, so they bring up the adults first, so I'm going to call this X. Okay, so $7.50 for every adult. And then $5 for every kid. Since they bring that up second, I'm going to call that Y, so plus 5Y. And they need to make at least $240. So what that's saying is I can make $240 or more. So greater than or equal to 240. Okay, now this is in standard form for us. Okay, so I think we need to keep it in standard form and use our x-intercept and our y-intercept methods, because then that also tells us how big to make our graphs. Okay, so on here, if I take and find my x-intercept, that means your y is 0, so you can cross out this 5y. And so we would need to take 240, and we would need to divide it by $7.50. If you do that, you're going to get 32. Okay, so there's my intercepts. All right, then for our y, if we're finding our y-intercept, remember you put a 0 in for x. So I really have 5y is equal to 240. So I'm going to take 240 divided by 5. I'm going to get 48. All right, now I know how big to make my graph. So if I'm making my graph off here to the side, again, our x was our adult tickets, and our y was our kid tickets. I'm going to remember to put a title on here. I'm just going to call it theater. All right. For my adults, I got to get up to 32. So I think I'm going to go like 10, 20, 30. And I didn't leave enough room really to put my scale, but I'll try to sneak it in there. 20 and 30. So really everyone is 5. I just don't want to label each one. All right, looking at my y, 10, 20, 30. Oh, that's not going to work for us. So maybe I'll actually go 10, 20, 30, 40, 50. So I'll do it by true tens. So you don't have to have the same scale for each of them. All right, so putting my x-intercept at 32, that'd be like right there. Putting my y just under 50. Since, again, they can sell exactly 240, we know that that's a solid line. And then we want to make that or more, so we would shade above on there. Okay, and then typically you have to also give 2 solutions to that. So if we want to give 2 solutions, we just need to pick a point somewhere up here in the shaded region. And I like to make it super obvious, so I think I'm going to go like 35, 40. So 35 adult and 40 kids. All right, maybe I'll go 20 adults and 50 kids. So 20 adult and 50 kids. You can also take those numbers and plug them back into your equation and make sure that it's greater than 240 to be 100% sure as well. And that's it that we've got for you.